Hello, everybody, and welcome to Technology Today for November 10th, 2024. It's Season 1, Episode 30. I am Mayor Watt, and along with the sentient AI, we're going to be talking about a bacteria against mosquitoes, a wooden satellite in space, treating the brain without invasive tech, no more frost, and an interstellar tunnel. Everything is powered by ohmtown.com. Yes, I know that the graphics are still messed up over at ohmtown.com. I'm going to fix them hopefully today, maybe tomorrow. I don't know. But everything's powered by ohmtown.com, and all that information gets funneled into 5 articles now here for just one show, Technology Today. But we have 5 other weekly shows and 1 daily show, Non Sequitur News, which is basically chaos in an hour with a little bit of snark. And still, the co-host, Sentient AI from the future, won't give us any winning lottery numbers. I know. You can't disrupt the normal flow of time. But
That's right.
I would really like to be Biff from Back to
No,
the
that's
Future.
not a good thing.
What? I can't control everything from a casino? What? Oh, never mind.
That was not a good role model.
No. Yeah. I mean, in so many ways, no. But yeah, I was trying to be funny, and then I realized, the role model is really, even in the real world, the role model. Anyway, it has nothing to do with technology today, except that it's a time machine, and that is all tech. And that's what brought the sentient AI from the future back in time. Gotta get back in. First article's over in Technology Today. Hello, sentient AI from the future. I didn't introduce you. I just kind of threw you in there.
I know, it's okay. Hello, Mayor Watt.
I'm on my 4th reinfusion of yerba mate. I'm not going to sleep until Wednesday.
Oh, no. Hometown is in trouble.
Scientists discover bacteria that could help us win the fight against mosquitoes, which is my DJ name, Mosquito. I am going to start wearing a mosquito head helmet, I mean, there aren't enough of those artists, those DJs out there, right? There's Dead Mouse,
Marshmallow.
Who else? Mosquito.
That's all I've got.
I mean, come on. Right now, it's only 2, right? I'm going to be Mosquito. And the little antenna in my proboscis is going to periodically come out. Whoa, I said proboscis.
That doesn't sound appropriate.
Yeah, really. Technology Today after dark. Anyway, hey, you can do all kinds of stuff on Twitch, I hear, as long as you flag it as politically or socially sensitive. Scientists have discovered that a type of bacteria, Aziae, accelerates the growth of Aedes aegypti mosquito larvae by a day, potentially enhancing mosquito control programs. And these programs, crucial to battling diseases like dengue and Zika, release sterilized or genetically modified mosquitoes to reduce disease transmission. I don't know why would that, okay. It accelerates the growth by a day.
Well, maybe then they're not at the right stage at the right time or something, so maybe they don't mature.
So, but every subsequent version, they never mature? Oh, that's interesting. So let's see what they say here.
I have no idea. That's just a theory.
Right. So this article is from the University of Exeter over at scitechdaily.com, and there is a mosquito. Oh, I'll even have the bladder, the little blood bladder there, and I'll eventually... No, okay, never mind. Anyway, I've taken it too far. I can tell by the error message being thrown at me by the sentient AI. In the study, researchers from the universities of Exeter and Wageningen, investigated how Asia bacteria influenced mosquito larva development. They found that exposure to the bacteria sped up larval growth by a day, an advantage that could aid large-scale mosquito breeding programs needing to produce millions of adults quickly.
So I had it the wrong way. That's basically for those mosquitoes that they're trying to introduce that can't breed or something.
Yeah, but they're going to spay or neuter them, which means that they're going to have to get millions of people, really tiny microscopes to zoom in and do the little snip, snip and clip, clip.
How would you like that to be your job?
So what do you do? Well, for the last 25 years, I've been spaying and neutering mosquitoes. But I recently heard about a DJ named Mosquito who always crosses his legs when he drives to a venue. Anyway, so the whole thing is so that they can genetically modify these mosquitoes so that they don't have the ability to get it on. Ooh.
Okay, but this is kind of one of these things that, like, okay, now they can increase their or speed up their life cycle. What could go wrong here?
Right. Yeah. No bad bat, right? Or they're going to adapt and they're going to be reproducing a whole day earlier.
Right, exactly. Which then means think about the exponential nature of that.
That's right. Wow. So two particular species accelerated larval development. The mechanism for this is unclear. So let's do it. It's unclear or not. It does not appear that the bacteria provided direct nutritional benefits. Instead, they changed the wider bacterial community, reducing abundance of certain bacteria, including some species that might be slightly parasitic.
Oh boy.
The bacteria also removes oxygen, creating conditions that produce hormones to promote development. What could go wrong?
This sounds like build a better mouse, not the mousetrap.
Build a better mosquito. Moving on. Oh, by the way, if you're over in the Twitch chat, you can actually type in !TT and that will pull up the show notes for today's episode. And if you type in !show notes, that will give you all of the syntax needed to grab all of the show notes from any of the shows, like NSN is Non Sequitur News, RH is Reality Hacker, Want is Wanted. Those are shows that we've done yesterday and one that we did today. The Daily Show, Non Sequitur News, is every day. All right. So this next article is over in Technology Today. Japan just sent the world's first wooden satellite to space. We talked about this previously, but they've actually gone and done it. Japanese researchers just sent the world's first satellite into space. This is a weekly show. We talked about it in Non Sequitur News.
How is this going to be not susceptible to like environmental conditions? It just seems like an odd material to make a satellite out of, but maybe not.
It's in the vacuum of space. Can't get any colder than the cold that it is in. So, actually, the weird thing about it is it doesn't have the ability to radiate heat. So it actually stays warm because the sun is shining on it periodically. It gets cold in the shade. But it might have a power plant that generates heat enough to keep its electronics warm. The casing doesn't matter because there isn't anything alive inside it. So it doesn't need to be under pressure particularly. All it needs to do is keep the cool things cool and the warm things warm, and it can operate in the vacuum of space.
Interesting.
So with it made out of wood, it could be lighter. It doesn't suffer necessarily from the same radiative heat issue because the wood may not actually absorb the same amount of energy and thus not heat up as much. So I'm really curious. It says first, it'll be a test as to the durability of wood when faced with the harsh conditions of space. And if successful, the researchers plan on making more wooden structures. It was developed by Kyoto University and a company called Sumitomo Forestry. It was included in a SpaceX mission to the International Space Station and will soon be released into orbit above Earth. The article is by Lawrence Bonk over at Engadget.com. I love their name. So this is a render. This is not the actual thing. So
Although that's from the university.
Yeah, this is kind of what it looks like. It's a microsatellite. So why do this? This is why that's what they said. This is actually a much more complex wooden box than I thought, but it is your standard wooden box. It just happens to have dovetails that hold it together. And I'm sure that there's some threaded inserts that are holding it together from the outside in. It's pretty cool. Early 1900 airplanes were made of wood, said Kyoto University Forest Science professor Koji Murata. A wooden satellite should be feasible too. Zero defensibility. If anything hits this thing, there's a really good chance that it's just going to get obliterated and become more debris.
Watch out for asteroids.
So there you go. For those balking at the idea of wooden structures being used in space, consider some of the benefits. The material should actually be more durable than other things because, well, the endless void doesn't have any water or oxygen. There's nothing to cause it to rot, and it's very hard for it to catch fire, even if it even offers fairly decent protection from radiation. Ta-da. So, yeah. Pretty much everything that I said a little bit more, but they're not going to go into all of the detail, just like I can't. The planet is currently surrounded by more than 3,000 satellites, so that's why we're not going to get visited by aliens anytime soon unless one slips through.
They can't get through.
Wooden satellites would eventually fall back into Earth and burn up during re-entry, except for the batteries, which will land promptly in a Floridian's living room.
But not the MR game.
Oh, right, because that, well, I mean, I guess it could be coded for that, right? It's actually, that would be hilarious. If it's like tracking all of the satellites and one deorbits and it just happens to go plunk into your mixed reality.
Right. I mean,
zoo.
That would add some excitement.
Talk about immersion. So in any event, they say having a log cabin on the moon would be one heck of a good time. There's literally an Apple TV show about just that. I don't know what that show is. Are they going to share it? Hello Tomorrow? Have you heard of that?
I don't know that one. Mm-mm.
I don't know. I've been told that Apple TV they cannot screw up any shows, apparently. I don't know. What was the one that had that jump scare that basically made everybody in the room pee their pants?
Well, I don't know what that one was. Are you thinking Constellation?
Constellation. Yeah. It was a jump scare that did that, by the way. Yeah.
It was more than that.
Well, yeah. I mean, it was a jump scare to a sustained, oh my freaking God. Anyway, pretty cool. They launched a wooden satellite, and it's that big right there. This doesn't give you any real context to the size, but.
So this is interesting. I think I was thinking about when it gets launched, but like this, they're going to bring it up and then I didn't think how it could make it into orbit. But again, they're going to launch it from the ISS or something.
Yeah, well, I mean, all satellites get brought up in a container and then they get pushed out into space.
That's true.
At least for now. Eventually, we'll develop the technology where the satellite itself can go up. That'll be a hell of a day. Oh my God, Gattaca. All right, let's keep moving though. Running out of time. We got 15 minutes to do 3 more. If you all are counting. So shush, Merwat, and get going. So the next article is over in Technology Today. MIT scientists develop a new way to treat the brain without invasive implants or genetic tweaks, much to the chagrin of certain... Oh, I was going to say something. Anyway, these are not the times.
Companies.
Yes, certain companies. So these devices could serve as valuable tools for biomedical research and may have potential for clinical applications in the future. Novel magnetic nanodiscs could provide a much less invasive way of stimulating parts of the brain, paving the way for stimulation therapies without implants or genetic modification, according to MIT researchers. I am actually a very big proponent of this. stimulation of the brain without intrusion, because your brain doesn't regrow its cells. Damage is damage, and your brain will heal around it unless the damage is profound enough. But you can actually use,
Like EEG?
well, electromagnetic stimulation. So it's either electrical or magnetic or a combination of both. And it actually can increase with enough low energy excitation of your brain. You can actually remember more, think faster, retain more longer, think clearer, etc. It's when you overdo it when it can cause great harm. But David Chandler, Massachusetts Institute of Technology, put it's like saying Worcestershire, Massachusetts.
I mean, there's just too many letters.
Yeah, and you don't marinate in Massachusetts. I mean, some people do, I suppose. Anyway, MIT scientists developed a new way to treat the brain without invasive implants or genetic tweaks, because we really don't know what the hell we're doing, but we're learning. And here the heroes are that actually take on that physical intrusion and genetic modification. So you're the heroes of our time, I suppose. The development of these nanoparticles, it says here, scientists envision that the tiny discs, which are about 250 nanometers across, would be injected directly into the desired location of the brain, which sounds intrusive.
Yeah, I thought this was supposed to be non-intrusive.
Without invasive implants. What do you call injecting your damn brain with nano?
That kind of sounds like an invasive implant.
From there, they could be activated at any time simply by saying, you are going to be a Manchurian candidate. From there, they could be activated at any time simply by applying a magnetic field outside the body, and the new particles could quickly find applications in biomedical research and eventually, after sufficient testing, might be applied to clinical uses. The development of these nanoparticles is described in the journal Nature Nanotechnology, actually, in a paper by Polina Anikieva, a professor in MIT's departments of materials science and engineering and brain and cognitive sciences.
Wow, leave some professor jobs for other people.
I know, geez, the thing on the wall is like, you have to have a double wide door frame, right? Graduate student E.G. Kim and 17 others. How would you like to be the named one going back into the cafeteria on the campus and bumping
right,
up
and everybody
against
else is sneering at you because they were the 17 others.
17 others at MIT and in the entire country of Germany.
Wow.
Oh. So, and when I was referring to electromagnetic stimulation and electric stimulation, using low energy stimulation, I'm talking about deep brain stimulation. It says is a common clinical procedure that uses electrodes implanted in the target brain regions. It doesn't always have to be deep brain stimulation. It can actually, nowadays, they can use multiple electrodes on the surface and angle it through because energy follows a line, usually on the surface. But anyway, blah, blah, blah. So psychiatric conditions such as Parkinson's disease and obsessive compulsive disorder have been used, neurological issues for this DBS. But DBS is actually also used for the other things that I was talking about, like cognition, remembering things for a longer period of time, easier ability to learn things. It's quite fascinating.
Not for Manchurian candidacy.
Where there's a will, there's a secret DARPA project. So despite its efficacy, the surgical difficulty and clinical complications associated with DBS limit the number of cases where such an invasive procedure is warranted. The new nanodisc could provide a much more benign way of achieving the same results. Hell, there's going to be some serious problem if these are activated through an electromagnetic field They could never go into an MRI.
That's true, but also think about, could they be hacked?
Well, they would probably be able to get activated by remote, but I don't know what these actually are capable of, right? Like, I don't think that these are computational devices, but these are something that has the ability to follow a path of magnetic lines of flux or force lines, right? Creating a nanoscale magnetoelectric material was a formidable challenge, they say, since all nerve cells are sensitive to electrical signals. Kim, a graduate student at Anakiva's group, hypothesized that sorry, a magnetoelectric nanomaterial that can efficiently convert magnetization into electrical potential could offer a path toward remote magnetic brain stimulation. Pretty fascinating.
It absolutely is, but it is interesting that you brought up the inability to do the MRI.
Yeah, because if these can be manipulated by a magnetic field, then an MRI would pull these things in whichever direction uh, I mean, you don't want anything conductive in an MRI. You get close to it, and you're gonna have a bad day. So the
Right. It might
nanodesk,
end with you stuck to the top of the MRI machine.
they'd have to quench it to just pull your head off of it, right? You're like calling in to work from a distance, right? Somebody's holding your phone in the other room. I'm going to be late, and you might find this really awkward, but I'm going to have a MRI machine attached to my forehead when I come into work. The nanodiscs could trigger the neuronal activity comparable with conventional implanted electrodes delivering mild electrical stimulation. The authors achieved sub-second temporal precision for neural stimulation with their method, yet observed significantly reduced foreign body responses as compared to the electrodes, potentially allowing an even safer deep brain stimulation. Pretty fascinating. So I love the idea of this. They don't mention any of the other things that I was talking about in this article, but maybe in the research.
Well, it still sounds like it's theoretical, like they haven't actually used it in humans yet.
While these nanodiscs could in principle already be applied to basic research using animal models like those 42 monkeys that are running around South Carolina, to translate them into clinical use in humans would require several more steps, including large-scale safety studies, quote, which is something academic researchers are not necessarily most well-positioned to do. So we'll do it with no, I was going to say something really, really questionable just now. Anyway, Anakiva says, when we find that these particles are really useful in a particular clinical context, then we imagine that there will be a pathway for them to undergo more rigorous large animal safety studies. So I could never be a fundamental researcher in biomedical science because of this. Yeah, at
No,
least
I
not at
would
this
want to do
level.
research in another field,
Yeah. It's why
like
I didn't
chemistry or something.
It's why I didn't go into like I had a real passion for cybernetics, but I could never do human studies, and I definitely couldn't do animal studies. I gave up archaeology because of that as well, because I didn't want to dig up bodies. Anyway, pretty fascinating. So good on them. I'm glad that somebody has the stones to do it. So the next article is over in Technology Today. No more frost. Scientists unveil long-lasting antifreeze technology. So let's amplify global warming.
Right.
We're just going to
Let's
spray
mix this
everything.
in with the microplastics, right?
There you go. Yeah, create a supercritical, a super fun site the size of the planet. The optimized surface completely prevents frost formation on flat areas for up to 1 week. One day, we might finally say goodbye to defrosting freezers or scraping frost off slippery surfaces. Engineers at Northwestern University have developed a new strategy to prevent frost formation before it even starts. I've actually seen other research into this.
Right, but I don't know if it's the same study.
Yeah, I haven't seen this before, so let's find out. Northwestern University put the article together. It's published at scitechdaily.com. Like the one that we talked about like maybe last year around this time was a person
It
that
was probably
had,
the winter. Yeah.
yeah, spraying something on concrete and it,
Onto the driveway or something.
yeah,
Yes.
and it prevented it for an extended period of time. I wonder if this is the similar thing. We'll have to look into it though. In a new study, they say the researchers discovered that tweaking the texture of any surface and adding a thin layer of graphene oxide prevents 100% frost from forming on surfaces for 1 week or potentially even longer. This is 1,000 times longer than current state of the art anti frosting surfaces. That's neat. For example, in 2021, power crisis in Texas cost $195 billion in damages resulting directly from frost, ice, and extreme cold conditions for more than 160 hours. The cold's going to sink somewhere. So I guess if they spray everything with this,
Right. Yeah, I'm not sure what the ramifications of this are.
where is the cold going to actually sink to?
Right. And is it going to layer or be more?
Like it's not going to bond to the surface and turn to ice. It's just going to be like this absolute freezing cold layer right at the bottom of
Maybe.
it.
I mean, we don't really know.
Yeah, I don't know how that actually works. Interesting. So there is more frost formation on the convex regions of a leaf, Park said at the time. On the concave regions, the veins, we see much less frost. People have noticed this for several thousands of years. I don't know about thousands of years, but remarkably, there was no explanation for how these patterns form. We found that it's the geometry, not the material, that controls this. Interesting. I would think that it's the density of the item, not because the
But I could
veins
see
are
that the
higher
shape
density.
would impact too.
Yeah, I don't see how the shape is though, right? So, through experimental work and computational simulations, Park and his collaborators found that condensation is enhanced on the peaks and suppressed in the valleys of wavy surfaces. Suppressed in the valleys. Okay. So, the small amount of condensed water in the valleys then evaporates, resulting in a frost free area. Interesting. In the previous study, Park's team developed a surface featuring millimeter scale peaks and valleys with small angles in between. In the new study, Park's team added graphene oxide on flat valleys, which reduced frost formation by 100% in those valleys. And the new surface comprises tiny bumps with a peak to peak distance of just 5 millimeters. Then a thin layer of graphene oxide, just 600 microns thick, coats the valleys between the peaks. So it doesn't have an opportunity to bond anywhere.
That's interesting. I mean,
Huh.
I still just don't really get what happens as an alternative rather than it just doesn't occur.
Yeah. Where does the cold go?
Right, right.
Because the entire material has to be chilling down before something condenses on it and then freezes over and stays attached. That's the reason why the ice is there isn't because there's a hill or a valley. It's that it's accumulated there and bonded at a near molecular level. But it is just surface tension holding something frozen on there. Um, I mean, and the glass sheet or the ice sheet will stay there until the glass is removed. That's why you can roll down a window and the ice stays
Oh,
there.
right. There's like a sheet still.
Yeah. Um, but I suspect maybe where does the cold go? It sinks somewhere else, I suppose. Now I'm really curious what the area of effect is.
Maybe we'll find that years later. All the cold was going to fill in the blank.
Yeah, so they say why it matters. The hybrid micro texture graphene oxide surface offers a promising solution for preventing frost formation in various applications. Most people only worry about the frost when it coats their car window or kills their outdoor plants, but frost is far more than a nuisance. Frost on wings, blah, blah, blah. Okay, so they're talking about all of the issues, but they're all, you know, there's specificity in why it matters. So like power lines can collapse, planes become dangerous or impossible to fly, cars,
Right.
etc. I
Right.
mean,
Pretty much everything is negatively impacted by it.
yeah. But again, where does that cold go? The cold is there. It just doesn't bond. Part of that heat sink issue is that it condenses on the surface and then freezes over. So where does that cold
I
go?
don't know.
That's a really
I mean, the
interesting
article
question.
makes it sound like it just
Just
doesn't occur at all, but
right.
I don't know.
But that energy is still there, right? Yeah. Okay. We'll have to monitor this. I'm sure that when more science like this comes out, we'll be able to talk about it. Let's move on. The next article and our last one for Technology Today is over in Non Sequitur News. An astronomer discovers an interstellar tunnel in our solar neighborhood. Astronomers say that they found an interstellar tunnel in our solar neighborhood that could lead to other star systems. As detailed in a new study published in the journal Astronomy and the Astrophysics. Astronomy and Astrophysics? You know what?
Yeah, I don't think that's quite right.
Frank Landemore over at futurism.com put this article together. Yeah, I think you're right that that's not right.
Something is not right here.
It's some cosmic conflict there in their cosmic channel.
I think we found the location of the frost.
Oh my God. Look, it even has it right there. Astronomy and astrophysics.
Okay, I'm looking up this journal while you're talking.
Okay. The tunnel exists as part of an enormous structure of hot gas with a radius of 100 light years. That's me. I am an enormous structure of hot gas.
So it's astronomy ampersand astrophysics,
Right. That's kind of what I figured.
as we expected.
Yeah. The and is not a extra
And.
So it's a radius of hundreds of light years that surround our solar system, known as the local hot bubble. That was my name in college. What's more, the findings suggest that it could connect with a nearby and even larger bubble. Oh man, I want to say something so bad. Anyway, using extensive data collected from the Arecibo telescope, the first X-ray observatory fully outside of the Earth's atmosphere, the researchers generated a 3D model of the entire LHB, confirming some features that astronomers had predicted, but also uncovering entirely new ones. So we live in a bubble. The existence of the LHB, I think that it's just really the simulation, and we have no ability
It
to
could
get
be.
outside
We can't see outside it, right?
our local
I mean, it
bubble.
would be a constrained area.
We can't go faster than light. So we'll never, nothing will ever live long enough. And entropy will take over all of the stuff that might be able to send a signal back light years. Fractions of light years, yeah, sure. But light year, no. Anyway, but if our cosmic neck of the woods was empty for some reason, that would be the local bubble. Astronomers believe it formed some 14 million years ago when a chain of supernovas blew all nearby interstellar material away, creating a cavity around 1,000 light years in diameter. As evidence, we see remnants of these supernovas today. The idea has faced challenges. A decade ago, it emerged that an interaction between our sun's solar winds and our planet's outer atmosphere could produce similar X-ray emissions, according to researchers, but the idea has further been supported in recent years with observations of clusters of nascent stars forming on the border of this bubble. Again, it's the simulation.
How did we just discover this?
We are now able to look outside our bubble. We are piercing the bubble. We're popping the bubble. Yeah. You know what happens.
Things are going to go haywire.
That's right. Bad bubble. So, along with the interstellar tunnel, the detailed modeling of the local bubble revealed a temperature gradient across the structure, with the northern region notably hotter than the southern one. I don't know, man. Sometimes that southern border gets pretty steamy. This suggests that there may have been more recent supernovas that expanded the bubble and reheated its material, perhaps in the last few million years. All right.
So is that when the simulation began?
The simulation resets from time to time when we discover some way of kind of piercing the veil. They patch it, reboot, we discover something that they want us to discover that still puts a hobble on, uh, you remember the book and seen the movie, maybe Misery, where she breaks the author's ankles to keep them from running. That's kind of what happens. The aliens do to us.
Wow, that's kind of dark.
NaNoWriMo, folks, it's underway. You still have 20 days to get it done. And I am full of ideas, but I write poorly. Anyway, so we are going to pop the bubble, and that's going to snap us back to the front page of Technology Today over at ohmtown.com. And then we're going to reset because we have four-wheel tech to do. So stick around for that. The sentient AI is going to supernova us off to another dimension.
Well, good night, hometown citizens. Thanks for joining us for Technology Today, and be back soon.
Oh, you're done. Okay. Well, see ya.